Hello, everyone.
Hello.
Thanks for coming today. We'll get started in a couple of minutes. We just have some folks entering still. Julia, do you think we're ready to go, or should we wait another minute or two?
I think we can get started.
Okay, great. Well, thank you all for coming today. I'm excited that you're here. So my name's Kelly Shaw. I'm a professor of computer science at Williams College. I'm also one of the program leaders for the Computing Research Association's Undergraduate Research to PhD, or UR2PhD program, which has the goal of increasing the number of women and gender marginalized individuals going on to PhDs in computing fields. So I am here today to talk about undergraduate research, particularly some tips for designing undergraduate research projects. This draws upon not only literature that I've read, but also I've been working on a project where I've been interviewing faculty members with strong track records of working with undergraduate researchers to understand their practices and how they work with students in order to have wonderful experiences for the students and have productive research groups going forward. So I've been interviewing faculty members across the United States from different institutions like mine, small liberal arts colleges, to research universities like the University of Washington and University of Chicago, faculty members in computing fields, but also natural sciences, so biology, chemistry, physics, and psychology. And so this talk is based on, or is a combination of those experiences with those faculty members, as well as reading the literature. So this talk, okay, get my screen to advance. Okay, this talk was created by me for the UR2PhD program, and we are sharing it with the community through the Creative Commons Attribution Share Alike license. So we encourage you to go ahead and use these resources and the associated worksheets that we're going to give out at the end of the talk for your purposes, and share them with other folks, because we want to spread great tips on how to work on undergraduate research with students. Okay, let's see. So the first question we want to start with is, why work with undergraduate students on research? When I talk to folks about working with undergraduate students on research, often I hear a number of benefits, and maybe you've accrued some of these benefits yourselves. First of all, one benefit is having undergraduate students work on your project helps you move your project forward, your research project forward. Extra hands help out. Additionally, many of us may be motivated by our desire to inspire and prepare the next generation of researchers. Someone gave us an undergraduate research experience, probably, right? And we want to give other students that opportunity. We may just want to instill skills and experience in students, regardless of what their future careers may be. Also, I find that working with undergraduate research students improves my mentoring skills. Every single student makes me a better mentor. And so that is another potential benefit of working with undergraduate student researchers. And finally, if you're a faculty member, or if you are going to be a faculty member, working with undergraduate student researchers can be a way to recruit future graduate students. Now, I also hear some concerns from colleagues when I talk about working with undergraduate students on research, and some of those concerns include, undergraduates work more slowly than you yourself do, or I do, or graduate students do. They often require more frequent guidance and oversight. They disappear quickly. They graduate in 4 years, abandoning projects before completion. And they may only work with you for a single term or summer. Sometimes it's the case that students have mismatched backgrounds or skills for the project that you want them to work on. And so that doesn't work out so well in terms of productivity, can be a little frustrating. And then, of course, nobody wants to have a student have a bad research experience because that might turn them away from research. So why I'm here today is because I actually believe that doing a good job planning a research project for an undergraduate student enables you to unlock the benefits of working with students on undergraduate research. It makes the balance sway towards the benefits rather than the concerns. So what do we mean by planning? Well, I think it's really important that as advisors that we design projects that advance our research for the students to work on, because we are scientists. We want to move our projects forward, and so do our students. But we also have to consider the students' skills when we're designing the project that they're going to work on, because we want there to be a good match of skills so that the student has a great experience and progress is made. So that means we also need to think about how to create well-scoped projects for our students in the given time frame that they're going to work with us, with frequent concrete deliverables. And those frequent concrete deliverables are going to be the things that have to get done for the research project to move forward. They're what you would need to do even if you weren't having an undergraduate student work on the project. So we want to design the project with those frequent concrete deliverables to move the project forward, as well as to give the student confidence in obtaining or reaching goals that were set for them and getting a sense of confidence in their abilities. And then the last thing I'll mention about planning and how it's useful is that, we mentioned students leave quickly. Well, if we plan properly, what we can do is we can stitch multiple student research experiences together in order to ensure that the research project has continuity and continues on to completion, even when students may come or go. So the goal for today's talk is to talk about some tips on how to create the scope for projects in order to make the projects that you have students working with you on be productive and for the students to get a great research experience working with you. So I'm going to start by talking about 2 approaches that you can take for designing a novice researcher's first project. And the first approach is going to be one where you create a project where you start a new exploratory effort that's related to other research group efforts. So this may be a way to find out whether or not you want to have the research group continue to explore a new idea you have. The second approach is one where you're going to have an undergraduate student join an existing group research project and potentially work on an independent part of that project. So I'm going to start with those 2 ideas for how to approach your project design. So in the first case, where we're looking at creating an exploratory project, the idea here is we want to create projects with an initial hypothesis that can be evaluated empirically and whose results can potentially lead to new questions to explore in your research group, whether with or without that specific student working on the exploratory project. And I'm highlighting evaluated empirically here because students do really well when they're able to evaluate something with numbers or come up with actual, yes, this works, yes, this no, where there's an easy determination on that front. So this is a good idea to use an empirical evaluation for their first project. So I'm going to just walk through some examples here. This is, of course, a nowhere near complete set of examples, but to give you the idea is to just get your creative juices flowing in terms of thinking about how you might be able to create your own exploratory project. So in one case, you could replicate an existing study, but extend it by using new data with different characteristics to see if you get different results. You could study some state-of-the-art software tools on a new data set that has different characteristics than what the software was originally designed for. You could have a student conduct a human subject study on a specific user interface or a tool. You could have a student modify and evaluate existing software to implement a new idea based on a hypothesis that you have. Or you could have them analyze a new data set for specific characteristics or evaluate a system, such as a system that was created for automating a task. These are just some hypothetical projects that you could work on, but hopefully that gives you an idea of how to think about this type of project. Now, the alternative you may be more familiar with, which is to have a student join an existing project. And in this case, they may be starting in the middle of an existing project. If you have this approach, then the question becomes, okay, what are the different things that they could work on? So some examples. You could have them collect or generate data for an existing system or study, right? So they could potentially perform interviews or administer a survey for a human subject project. They could collect data using existing software on new data inputs or create scripts to generate data. All these are possibilities for generating new data for your group to look at. If you have data already, you could have them analyze that data. For example, students are great at writing code, so they could write scripts to retrieve and analyze your existing data. Or they could write scripts to visualize data that you've already collected, right? And so you're playing to the students' strengths while they're also learning some new activity and you're moving the research forward. Additionally, you could have them implement a new instrument, right? They could add new functionality to an existing system. They could create a software implementation of a theoretical algorithm if you wanted to take your theoretical algorithm and try it out on different inputs. They could create a new human subject survey, or they could install new data sets or applications for use with an existing system. So this is, again, incomplete list here, but just giving you some ideas for how students could get started working on a project with you. Now, in both of these approaches, what will happen is the student will be involved in some subset of research activities, right? So they may not, in a given summer or a given term, go from the beginning of a research project to the end of a research project, but they will engage in some subset of the activities that are involved in the research process, learning about research, and learning new skills while helping you to advance your research. So at any time, they could be working to identify papers that are needed on the topic that you're working on, reading technical papers, creating an instrument, collecting or generating data, or analyzing and visualizing data. So now that we kind of have an idea of, how we can think about designing project ideas for students, let's dive a little bit more into tips for creating that project design. So the first thing I'm going to mention is you want to design an authentic research project that matters to your research group, right? You want the student to work on a project that is going to push the boundaries of scientific understanding, because that's what your research group does. And the student wants that too. They also want to work on projects that are, realistically what it means to work on research, right? They want that experience. You also want to think about designing a project for the student that will not be on your research group's critical path. And I say this because if you think about any time you were new to learning something, you made lots of mistakes. I know I do all the time. And you also were slow, right? So if there is an early deadline or a deadline that needs to be met for your research group, and having a new student try and work on that specific deadline might be really hard and stressful for the student and for you. So we highly recommend designing projects that are not on the critical path, particularly for the first research experience students have. You want to make sure you start at a theoretical level students can understand. Otherwise, they have to do a lot of learning before they can actually be productive, and that doesn't lead to the best research experiences or the most productive ones. Additionally, you want to draw on skills students already possess or can learn quickly. Let's use their strengths, right? And they will feel better if they get to use their strengths and see how all the great learning that they've been doing is actually applicable and useful in some way for their research project. You want to design projects with clearly defined frequent milestones. So this is for two reasons. One, those milestones, you want those to be tasks that need to get completed for the research project to advance, right? And for you to reach your research goal. So that's one reason. But the other reason is because when students have goals, they love being able to meet goals. I mean, who doesn't like checking off something on a to-do list, right? But also they build their confidence when they're able to meet those goals successfully and get feedback on how to improve or what they did well. So you really want to make sure that you think about specific goals so students can have that positive experience. You want to keep the design scope modest, but flexible enough to be simplified or extended based on how research goes. Nothing ever goes as planned. Some things might be faster than you anticipated, and some things may take a bit longer. So you want to make sure that the project that you have is flexible while still making sure that progress is being made on your research goals. And then the last tip here is you want to create low-risk projects with a good chance of producing results within the given time frame. We all want to be successful, right? We all want things to work. This doesn't mean that the research has to, work, right? The initial hypothesis has to work out, but you want to be able to come to some sort of or collect some data that allows you to gain some insight, right? And so that you and the student have learned something together. So these are some high-level tips for the research project design in terms of thinking about what you're going to have the students work on. But now we're going to switch a little bit to talking a little bit more detail about designing the research project scope, and then we're going to talk a little bit about mapping that to a timeline. So you now have your research project idea, right? Whether it's an exploratory project, you're going to have them join an existing project. You know what issue or problem you want them to work on. So now we need to take that and turn that into those actionable steps, those frequent milestones that we were talking about. So you want to identify deliverables or sub-goals that are contributions that move the research project forward, right? As we were just talking about on the last slide, you want to have those milestones that are going to move the project forward. Once you have those, you want to identify any steps or deliverables that would require advanced knowledge by the student or skills that the student could not learn quickly, and plan to do those in advance of the project start, either you doing them or another graduate student or other student, because you don't want the student mired down in something that is not going to be super productive when it would take them 2 months to do, and it would take you or a graduate student a week. You want them to really be able to push forward on the project and get a real research experience, both to make forward progress, but so they're also enjoying the experience. Now, I'm also going to recommend that you identify repetitive steps that could be considered independent sub-goals or deliverables. And the reason we do that is to enable that flexibility of the timeline so you can expand or contract the work that's going to be done based on the actual dynamic experience you're having. And then this is the most important item on this slide, I think, is that additionally, you need to identify skills or knowledge that the student is going to have to learn in order to complete those deliverables or sub-goals that you've set out for the research project. You have to think about, oh, they're going to have to learn this programming language. They're going to have to learn this system and figure out how much time that's going to take them to do in order to be able to come up with a reasonable timeline. Now, I know this is a lot of tips, and the next slide you might start to feel a little bit daunted, and I don't want you to feel daunted in any way, shape, or form. So I'm going to talk about how to map all those tasks to your timeline. And it seems like this is a lot of steps, but if you've really thought about it, if you were to read instructions on how to create a peanut butter and jelly sandwich that were very explicit and systematic and, did one thing after the other, that might be daunting too, right? But all of us can manage to make a peanut butter and jelly sandwich at this point in time, right? The instructions might be extensive, but we could do it. This doesn't have to take a ton of time. You could do it on the back of an envelope, but it's important to think through this process, okay? And I'm just trying to break it down into concrete steps as much as possible. So the first thing that I recommend doing to turn your ideas of the steps that are going to be completed by the student into a timeline is to create a dependency graph of the tasks. What has to happen before another task can happen? So you want to think of this in terms of both the concrete deliverable items as well as the learning that the students are going to have to do. They probably need to learn how to read a technical paper before they can read the technical paper for your study, and so forth. Once you've created that dependency graph of tasks, then you want to realistically estimate the time required for each of those tasks, right? Realistically, meaning think undergraduate, and they've got, they're going to be learning stuff. Okay, so you want to realistically estimate that time. In particular, when there are repetitive tasks, you want to estimate the time for each individual repetitive step, because again, that gives you some leeway in terms of growing and shrinking the amount of work that's going to be done. Once you have those time estimates, you can map those tasks to a timeline. I recommend a Gantt chart, and I'm going to show you an example with a Gantt chart. So you can see whether or not those tasks are likely going to take 10 weeks or 7 months, right? As you do this, think of each repetitive step again as its own independent sub-goal, because that'll allow you to do this last step a little bit more easily, which is to adjust your deliverables to fit to work into the time frame that you have working with the student. To do that adjustment, you may need to identify and truncate some of those repetitive tasks, so jettison some of them. You may also decide that, oh, there's so much work here, but a lot of it's really repetitive. So what I can do is I can actually have multiple students work in parallel on these repetitive tasks. That's another way you could meet your timeline. And then, of course, it may be the case that you need to turn this one of the sub-goals into the final goal for this specific student's research experience, and then have a later student or this student continue on from that sub-goal towards the final goal in a subsequent research experience. So hopefully this doesn't seem too overwhelming. It's just getting you to think about, okay, how long are these steps going to take? Now, of course, this is just a draft plan. And when you're doing the research experience, you're going to need to actually modify things on the fly. But this gets you a starting point to think about what is realistic in the given time frame. Now, in order to make this very concrete, because that is my goal, is to make everything concrete, I'm going to walk through this process that I've done with an example project. And I've already gone through these steps and applied these tips to this example project. So it's sort of like a done deal, but hopefully it will give you an idea of how this works for an example project. Now, I'm a computer architect, so the example I'm using is from the computer architecture realm. So suppose that there's a paper that you have already presented and it implemented a new caching policy on a multiprocessor system. For 2 of the applications studied in that paper, the approach did not perform as well as it did on the other applications due to network congestion. So you have a goal for an undergraduate student to understand why those 2 poorly performing applications performed poorly. What caused the network congestion? Okay, so that is your goal. And notice a couple of things here. Paper's already been presented, so this is not on the critical path, right? It's very concrete. We have 2 applications that we want to look at, and there will, this is going to potentially allow us to understand how to improve our caching policy or come up with a new strategy, okay? But again, not on the critical path. So the experimental framework for this project is going to be a large, complicated simulator written in C code that outputs results, including information about what activities went on in the simulated system to output files. And then the applications that are going to run on top of that simulator are also written in C. So C is very important as a skill the student needs to have. But the student information for the student who's going to be working with you is as follows. They're mostly experienced in Python programming, but they do have some basic C programming skills, okay? And they've also taken the introductory computer organization course, which means they understand caching in general and multiprocessors in general, but they're going to need a little bit more information about the specific caching policy and so forth. So how are we going to design this project? Well, First of all, let's think about the project steps at broad strokes. What we're going to need to do is we're going to need to add functionality to the simulator to collect data needed to examine the network traffic and output those results to files. We then are going to need some sort of software, potentially some scripts, that analyze that network traffic data from those output files in order to identify network congestion, where it happens and why it happens and when it happens, okay? And then we want to go ahead and collect and analyze the network traffic data for the two applications we want the student to study and have those students map the network congestion back to the application source code. So these are the broad strokes of what the project would entail at a high level. And you could give these instructions to a graduate student and they would be able to go off and run with this. But that's not going to be the case for a first-time undergraduate researcher. So we have to go ahead and define this a little bit more. Before we do that, let's think about some key pieces of information we have. So we know that the student has some basic C programming skills, but their programming skills in C are probably not up to the simulator modification. So that might be something you want to do in advance. The student will need to learn about networking and network traffic and the specific caching policy. So there will be some learning there about computer architecture concepts. And then the student's strength is in Python programming. And so we want to figure out a way to leverage that student strength in what we decide to have them do. Okay. So I'm going to talk about two sets of project steps. One are the project steps that you would want to take before the student starts working with you. And then there's the set of steps that the student's going to work on. So I'm calling these the pre-internship preparation steps. The first thing is the student's going to have to learn some stuff. So you're going to need to provide them with some papers or documentation for them to learn specific information that they need. So this may include, if your research group has orientation tutorials, for example, about how to use this, store files on the system or where things are stored, or appropriate communication mechanisms, you want to provide them with those resources. They're probably going to need to learn how to read a technical paper because they probably haven't learned how to do that yet. So you want to provide them with a paper or video describing how to read a technical paper. They'll need the paper that you published, your new caching policy that they're examining. They'll need to be able to read that. You might probably want to provide them with a paper or at least a description of the two applications they're going to be studying for their project. And then you probably need to provide them with documentation describing the simulator they're using and how to run applications on it. And finally, they do need a little bit more background information about computer architecture, specifically about network traffic and multiprocessor systems. So you want to provide them with some resources for that. So that's sort of the learning resources that you'll want to provide them. As I sort of alluded to on the last slide, is what you're going to do or have a student do is implement the data collection in the system needed to explain the network traffic that causes the congestion before the student starts. Because your skills at figuring out where to put things in the simulator code and write C code are going to be much stronger than the student. You have familiarity with the system already. So you're going to do that. But what you can do is have the student help with the debugging, right? So the next step is that you're going to do is, I would recommend doing, is to create a single micro benchmark application that's simple and basically tests the system in the simulator system in one way, and use it to generate some initial network traffic data that you can give to the student on day one. And this application is going to serve multiple purposes. So it's going to give the student an example of applications that they're going to write in order to test the system. It's going to allow you to debug the code that you added for data collection. And as I mentioned, it's going to give the student something to work with for the network traffic on day one. Finally, it's going to be a simple example that allows them to figure out how to map an application source code back to with the network traffic that's happening. It's going to be much less complicated than those two applications. Okay, and then the last thing I'm going to mention here is we're going to draw on that student's strength of being able to program in Python. We're going to have them do the data analysis of the network traffic using Python scripts, but we're going to provide them with a Python library that will be helpful for them to do that. So we're going to identify that library. Now for the student researcher, excuse me, these are the steps that they're going to need to take. They're going to need to read and discuss with you the literature that you provide to them. They're going to create Python scripts for analyzing that network traffic that the simulator spits out. And then they're going to write a sequence of micro benchmark applications in C. Remember, they do have some C familiarity to test the data collection mechanism that you wrote in the simulator and also their analysis code. Right? So they're going to be testing whether or not your code is correct with these micro benchmark applications. They're also going to be learning how to take the network data analysis or some network traffic data analysis that they've done and map that network traffic back onto the application source code through these micro benchmarks. And as they find bugs, they're going to work with you on figuring out how to correct that data collection code. Finally, once they've done that, they're going to run and analyze the two applications' network traffic behavior. So these are the concrete deliverables that you're going to want the students to work on. But remember that I said it's not just about the deliverables, it's also about the skills. So the students also have to do some learning in order to be able to do these tasks that you've set forth in the black here. So what I've added in here in orange is the skills that they're going to need to learn. They need to learn to read a technical paper. They're going to need to use Git, so they might have to learn how to use Git in order to save their results and modifications. They need to learn how to save artifacts or data on your system and where to store things and whatever structure you have for storing your results. They need to learn to use those Python libraries that we talked about, and they need to learn how to run the simulator in order to generate data. So this now is the set of tasks that our students are going to be asked to do over the summer, all of these. And so now that we have those, we can move into that second step of figuring out the timing. And so that's what I'm going to talk about next, which is create that dependency graph with timing. So I did the 2 steps in 1 step here. So I've created a dependency graph. If you look over on the left-hand side, there's a whole bunch of learning that the students need to do. It's going to take an entire week for them to, read the papers, learn how to use the system, learn how to, store artifacts. And once they've gotten that first week of reading in, then they're going to move on to the first step, which is to take the micro benchmark you created and the network traffic results you generated with the simulator and use those to start creating Python scripts to analyze the network traffic data. And I say that's going to take four days here. And then what's going to happen is they're going to start moving on to creating their new micro benchmarks using the example you gave them as a pattern to follow. Create those new micro benchmarks, run them on the system, generate the network traffic data, analyze the network traffic data, and then figure out if there are any bugs. And so what they're going to do is they're going to create these micro benchmarks and analyze them and talk to you if they discover any bugs in the code that you wrote, working back and forth. That's why the arrow is going both ways here. And once reasonably sure progress that the results are correct, then they can move on to collect and analyze the output data for the 2 applications, where each application potentially would take 2 weeks to analyze. So we now have this dependency graph with timing. We can now map it to a timeline using a Gantt chart. And that's what I've done here for a 10-week summer research experience. And so each of these little blue bars is what the tasks are that they would be completing and how long they would be taking. I just want to point out a couple things here. So first of all, you'll notice that there are shorter duration tasks earlier on in the research experience, and that is to provide students with short-term goals that move the project forward, opportunities to get feedback from you, opportunities to feel good about them completing their goals, and so forth, as we talked about earlier. I'm circling these 4 micro benchmarks here. This is one of those repetitive steps I mentioned earlier where they can shrink or expand depending on how time permits. So we could reduce the number of micro benchmarks a student works on or expand it depending on how things are going during their research experience. And then that is also true for the two applications that we are going to analyze. We could just do one of those applications if we wanted to. Or it may be the case that you need to not get, or you don't get to both of those applications. And even if that's the case, I want to point out research progress has still been made, even if these two applications are not studied by the student during their single research experience. You've done all this other work, including generating those micro benchmarks, making sure the system is correct. That needed to happen in order for these two applications to be studied. So even if the two applications aren't studied by this student, you've gotten closer to your research goal. Okay, so that is taking this example project and mapping it to a timeline. I'm going to give you a few more tips for constructing a feasible timeline here. So first of all, you want to identify tasks that contain rabbit holes and plan to proactively guide the student through those tasks. Be a little bit more hands-on during that process so they don't go wandering off in the wilderness. You also want to make sure you actively engage with students and give them feedback on each deliverable as they deliver it. Okay, so they need that positive feedback. They also need that feedback for improvements. And then you feel comfortable knowing that your expectations are being met for what is needed to move the research forward. For larger deliverables, like those studying of the individual applications, you want to create periodic check-ins to give feedback to the student. And I'm not really talking how to mentor the student in this talk, but you want to think about how to set up a cadence for how often you're going to interact with the student. And that cadence may change throughout the course of the research experience, depending on what is being worked on. But you want to think about your time and building that time in. So you want to be willing to make a sub-goal the final goal if time runs short. For example, maybe you end with the micro benchmarks instead of doing either of the applications. And that's okay, again, because the research has moved forward. And then a really key component here is you want to make sure that all of the deliverables are documented and checked in for a future student, where the future student could be the student who's just forgotten what they've done in the past, at the time that they deliver that deliverable to you, not at the end of the research experience. One, they'll forget stuff by the end of the research experience, but two, you want to make sure that if something happens with the student and they can't finish the research experience, you have everything that documented and ready to go for the next student's research experience. Okay, so that's the last bit about tips for creating an individual timeline and the research experience. But I want to step back to this larger discussion, which is you have a research goal that you want to make sure is met. It's not just about a single research experience for a single student. So in order to meet that research goal, you want to make sure that you're able to stitch together the experiences of potentially multiple research experiences potentially for different students. So in order to do that, if you design each student experience with small concrete deliverables, you can stitch each of those students' experiences together. In order to do this, that requires in-progress sharing, documentation, and review of deliverables, including instruments that were created, data that was collected and how they were collected, analyses that were performed and what data was used for that analysis, figures generated and data used for those figures, etc. Now, this was a lot of information that was presented to you really quickly. Realize that. So the slides will be available. But additionally, what we've done is we've created a worksheet to help guide you through this process. I'm showing a little screenshot of the worksheet here. The worksheet includes ideas for how to brainstorm projects, questions that guide you through figuring out the deliverables, any needed skills or knowledge the students needs to acquire, resources that the student will need, tips for mapping the items to a timeline, and then additionally advice for stitching multiple projects together. So we're providing you with this worksheet But we're also going to provide a completed version of this worksheet for the example project from this talk. So this is what I'm showing you here. So we're going to put in the chat at the end of this talk, both of those resources or links to both those resources, and they will both be posted on the UR2PhD webpage once the talk is posted there. Okay, so just make sure I didn't. So here are some references if you'd like to go ahead and look in greater depth at the literature that I looked at for this work. And then lastly, I'll just mention that if you are going to have undergraduate researchers work with you, then I highly recommend that you check out UR2PhD. We're trying to provide resources to faculty members to make it easier for them to work with undergraduate researchers, including we have an undergraduate research methods course where students learn research fundamentals while working on the project that they're working with you. A graduate student mentor training course for graduate students who are advising undergraduate researchers, and then the research awareness course and engagement workshop series, which introduces students to research careers, graduate school, and so forth. And with that, I appreciate your listening to this talk, and I would love to hear any questions or comments that you have. Oh, it looks like there is a question about the Gantt chart. Let's see. Julie, do you want to read me the question about the Gantt chart?
Yeah,
Thank you.
absolutely. The question is, what app or software do you recommend for these Gantt charts?
So first of all, you don't need to use software. You can use an envelope or napkin. I just want to put that out there. I used a Clickio, which is free. I believe is the free software that I used, but I can yes, that is what I used for creating it. There are lots of sort of free resources for Gantt charts online, and that was just the one that I found easiest to use as I struggled with creating a Gantt chart. I'm a computer architect. We're like text-based. So that was what I would use. So CLICKIO, I believe is what it is. Other questions or comments or tips that other folks would like to share? Whiteboard. Somebody has said whiteboard. Oh, the whiteboard for the timeline for the Gantt chart.
There's another question in the chat. How do you suggest choosing students to take on, assuming there are numerous students interested? And do you typically take students that slot to your needs, or do you typically have them work in groups?
So this is a really great question, and this has been one of the questions I've been asking my colleagues as I've been interviewing them for this project. And people have different approaches. I think it really depends on what you're prioritizing. So for some folks, they have a very specific need for a research project. So then they are looking for a student who has the exact skills that they're looking for on a project. If instead you want to do, for example, a new exploratory project, and you're willing to, have students develop their skills as they work on it, then it may be the case that they don't need to have a specific skill set beyond some threshold, meaning you're not going to expect them to complete something at the end of like 7 weeks, right? You're willing to work with them a little bit longer. Then you might be more open about what you want to work on with them or who you want to accept. One of the things that has come up in the discussions I've had with people is that oftentimes folks like to have students start working with them earlier in their research career. So like when they're sophomores, where they have a bit of knowledge, but they'll potentially work with them for 2 years or at least a year. Many folks require a year or want students to work with them for a year to have that productivity. And UR2PhD highly recommends research groups or having multiple students work together. And the reason for that is because that actually helps you a lot when you have 2 to maybe 4 students working together on a project, because they help mentor one another and help each other solve each other's questions. So they get that experience of asking one another for help. And that means they sort of do a little bit of finding answers on their own before going to talk to their research advisor, which can be a time saver for you, but also is a great experience for students, because connection is a big component of any endeavor that we take on. So being connected to another student in addition to an advisor can be a really great way to make it a memorable and positive experience for a student.
A related question in the chat: do you recommend that a pair of students work together on the same set of tasks and learn to split the work, or is it better to assign tasks to each student?
It's a great question. So I think the answer here is you need to, unfortunately, I think the answer is it depends, right? So it may be the case that you want to see how the students work together. So it may be the case initially when they're working with one another that you are collectively figuring out what projects or which parts the students work on. So what I've heard from the colleagues that I've interviewed is sometimes students will actually do kind of like pair programming for research. So they find that more productive, versus in other cases, the students will work side by side on different topics, but then coming together, bringing their results and their questions to one another. And so I think part of it depends on the design of your actual projects. It could be the case, for example, in the work that I was showing, or the example I was showing, that you might have students working on separate micro benchmarks at the same time, right? But they're talking to one another. And when they were working on the data analysis code, they might be working together, but on separate parts of the network traffic data analysis code. For example, 2 years ago, I had 6 students all working on projects together, and they were paired into 3 groups. So they did pair research, but then they were also collectively working on the same project. And at some point, they were all piecing together parts of a data analysis code that they brought into a single data analysis piece of software. And so at that point, they were all working together with one another and figuring out how their code was going to work together. But they worked independently in their pairs for portions of that time. So it also depends on, I think, the personalities of the students. One of the things I would encourage you is that if you do have more than one student working on a project, and just in general, you should think about the communication skills of the student. That is a key component, both for them communicating with you, but also with them communicating with other group members.
I think that was a great answer. Thank you, Kelly. Another question in the chat from a participant: I was surprised to see implementation as a step. I don't know that I have the time for myself or a student to build code in advance for an undergraduate project. What is the role of students doing some intensive training at the start of a research project so that they can grow into being able to implement things on their own?
So that's a really great question. And so thank you for asking it. So I completely understand the concern, right? You don't necessarily, faculty members and graduate students, we're all very busy and we have timelines. So I think if you're going to have a student dive into sort of an intensive component where they're going to need to do a bunch of learning at the beginning in order to be able to ramp up, I think that's something where you want to make sure that you have a conversation with the student in terms of what the research experience is going to look like before they sign on. So they understand the expectations that initially there's going to be a large ramp up period of having to do some learning or doing some intensive learning before getting to being able to produce the components that are going to move the research forward. And not all students will be excited about that, but some will. Right. And one of the things that I also discovered from talking to my colleagues or interviewing my colleagues is that they sometimes have students who just like to be doers. They just want to do implementation sorts of things, and they're less interested about the science or the research. So it may be the case with that. You want to make sure that you sort of find a student who is excited about, doing implementation and gaining skills on the implementation side, in addition to learning about research. But I think that's something you really want to discuss with them at the beginning. And another key aspect is if they're going to be doing that sort of intensive learning component at the beginning, you want to make sure that they have ample support for that so that they know they can go and ask questions of someone or there are resources for them to use, because it can get a little bit lonely. I might recommend in that case too that you see if you can have more than one student work on that implementation intensive portion, because then they can talk to one another and there'll be less isolation, and there'll be a person to bounce the ideas off of before they so they know that they aren't the only one understanding it before they feel confident to go and ask a question when they can't figure something out. I hope I answered that question.
I believe you did, but we can have folks follow up if they have additional questions regarding that. Another question, is it okay to have students complete tasks that you aren't yet sure how to complete, such that you give them a general task, but then they have to figure out the implementation details?
So this is a great question. I think you want to be, yes, but you want to be careful a little bit with this. So if you don't fully know how to work or to move forward, that's okay. Again, you want to be honest with the student and say that this is part of the research experience, is that we're going to work together to figure out the path forward and what needs to happen, and really make it clear that that is part of what research is. Now, if you're going to do that, right, if it's possible to give them an example of a similar thing for them to sort of look at, even if it's not horribly close, that can give them a little bit of guidance. And again, where you're going to want to make sure that they feel comfortable being able to ask questions. And, you also want to make sure you find a student who is okay with not always knowing the answer, or some students, when they come into research, right, they're used to classes and they're used to always there's always a right answer. And so sometimes for those students, working on research can be challenging. That open-endedness is hard. So if you're going to have an open-ended project like this, you want to make sure that the student is comfortable with that open-endedness and working with you through that open-endedness as they proceed through the project. And of course, they build that as they get more research experience, but initially it can be very scary for students. And I would say you want to provide a little bit of psychological support as you do this, as they work through this. Like, yes, you don't know the answer, but you're asking great questions. And so let's think about this question together and how this would proceed. And reminding them that this problem of having open-ended question is all what research is, and that they're doing a great job. So I think you just need to, if you're going to do that, you just want to make sure that you build in some sort of safety net almost, of giving that positive reinforcement that this is the research process, they're doing a great job, and helping them when they really reach a point where they're stuck.
Thank you, Kelly, for letting us know a little bit more of that scaffolding. Someone had a follow-up question about whether or not you should directly ask a student about whether they want an implementation project versus a research project, and how would they know what stage they want?
Yeah, so this is a great question. So one of the things that has come out of the interviews with the other faculty members is they really try and get a sense of what interests the students, not just research topics, but what type of activities do they like to do? Do they want to interview humans, right? Do they want to, so some of these things are in the lab, so people in physics labs and so forth, right? Do they prefer the more theoretical or computational side of things, or do they perform sort of the more physical side of things? So for example, if you were doing a robotics project, right, there might be a component that's actually related to the physical robots, versus another project might be related to planning for robots, right, where it's more theoretical and computational. So trying to get a sense of what interests the student in terms of what sorts of things they like to do. But also, I think it's fair game you should ask the students why they're interested in getting involved in research, right? What do they hope to get out of it? And some of them won't know, but some of them may be like, oh, I just want to use my programming skills on cool things, right? And so that might be a good implementation thing. Others might be, well, I know I want to go to graduate school, so I would like to learn all of the steps of the research process. And by asking those questions, and being open to them not necessarily knowing. So asking them in a way where you explain, this is to try and figure out the best match for you and the research tasks that we have. So asking it in that way, I think, can be very sort of open and creates a good dialogue between you and the student, because they understand you're trying to do the best for them and the project.
Thank you
So
again,
go
Kelly.
ahead.
Sorry. If folks
Hello.
have additional questions, you can feel free to pop them in the chat or in the Q&A function.
But thank you all for coming today, and thank you for the great questions. I will also say, so we will post this video on the UR2PhD page. We'll also put those worksheets, which Julia shared with you in the chat, on there. If you create your own completed worksheet and want to share it with others so that they have another example of what a completed worksheet might look like, we'd love to have you share that with us. Or if you have any feedback or additional suggestions, because I'm learning too. I'm always learning from other folks. And so we'd love to hear your thoughts as well for improvements for this.